Hey folks, Jason Garbus here. Hope everyone is doing well today. A couple weeks ago at the annual reInvent conference, AWS made an announcement about a new service called AWS Verified Access. And they talk about this as a new service, which is currently in preview, that lets organizations provide secure access to corporate applications that are running inside of AWS without a VPN. And they talk about it as being aligned with and supporting AWS's zero trust principles. So I saw this and I thought, hey, this will be interesting to talk about, and let's do an analysis of it and see what we think. So what we're going to do in this video is a number of things. So we're going to go through, look at the press release, we're going to look at the documentation, and make sure we understand the concepts, how things are wired up, what's connected to what the data flows will be, and see how this works, and really work our way through this so that we get to the all-important policy model. So what I want to do is make sure that we have these concepts in place. We'll talk about how the policy model, the policy language works, and then we'll critique it and find out what is it good for, where its weakness is, where do we think it's going. I also want to look at the pricing, because that definitely raised the question mark in my mind around how is this priced, how does that compare to some alternate solutions, and what would organizations be getting themselves into if they sign up for it and perhaps get a surprise in their AWS bill. So we're going to work for that in this video. So let's go ahead and dive in.
This is the press release. It's short and to the point.
What it does is it reiterate some of the concepts that I mentioned, but it's important for us to look at how they're positioning it. So they're talking about as delivering secure access to corporate applications without a VPN. So that's clearly, these are applications that, of course, are running inside of AWS. And AWS is taking advantage of themselves having control of the network and the entry point to be able to do something that we'll see to more finely and more dynamically control access into those applications. They promise that it's built on zero trust principles, and I believe it is. I think that there's definitely some merit to that. So they talk about enabling fine-grained policies, and as we look at the documentation and the policy language, we'll see that that is the case. And what they're doing is they talk about it as it evaluates each access request in real time and only connects users to the application if these conditions are met. So again, good, solid zero trust principles there. The important thing is that this is initially solely focused on web applications. And clearly web applications use a very short duration connection, really one connection per request for an HTTP post or a GET or things like that. So it makes sense to have this concept of evaluating each request as it happens. And obviously, if you're using something that's got a longer duration connection like an SSH or an RDP, where the user is doing lots of actions inside of the same connection, that concept doesn't make sense. So clearly, this is the approach that we're taking, and we will see that this is at least initially only focused on web applications. So using verified access, what you'll see is we define policies, and these policies are evaluated using contextual information about the identity from the identity provider, and also potentially about the device from the device providers or device management systems that they integrate with. And here's the example they gave. You can create a policy that allows only members of the finance team, based on group membership from the identity provider, to have access to the financial reporting application, and only using compliant devices. That's great. That's a great promise. That's a great policy. It's very reasonable. They support both their own identity provider, AWS IAM, as well as standards-based one, probably any OpenID Connect identity provider. The documentation you'll see is a little bit lighter on the third-party ones, and I have a question about that, but we can presume that it works. They also have mechanisms to integrate with third-party device posture providers, and they have an initial set that they're starting with. So let's go ahead and dive in. You can see here in the AWS console, I am logged in with my dog Scully's account. Don't tell Andy Jassy, but my dog does have an AWS account, although somehow he got it attached to my credit card. Here you can actually go through and do this. We're actually just going to walk through the documentation right now in this video, and let's go ahead and kick that off.
This is the AWS Verified Access overview page.
It's fairly straightforward. I'm not going to belabor this because it's very similar to kind of the overview and what we talked about They summarize some of the benefits. Obviously, improved security posture. Integration with security services is important because, in my mind, that's really the heart of Zero Trust, which is tying together events and data and context from a whole bunch of different systems. And in this example, we'll see how they've taken the first steps here and tied it into identity providers as well as device management systems. They have, of course, various ways to get access through this, through the standard mechanisms. And then the pricing, which we'll get to at the end of the video, is charged hourly for each application, which is different than typical Zero Trust solutions, which are typically licensed per user per year type of thing. And this one, could have some wrinkles with it, depending on the number of applications that you have. We'll revisit that at the end. So most importantly is how it works. And what they're doing is they're looking at each of these application requests, and essentially you're writing a policy, and that policy statement is evaluated against the context of that request. So it looks at information about the user, that is the identity, from the identity provider, can optionally look at device context, and it evaluates those and then makes a determination about should that access request be allowed to go through at that point in time. The way it works is there's this box here in the middle around verified access, and you can see that there's an instance you create, you set up a group, and then you attach it to essentially an application load balancer, which sits in front of your applications. It looks like they define an application essentially as a DNS entry. So that's how they do the math there. They have this notion of trust providers or trust data providers, which would be either the identity provider that's native to AWS or the external OIDC or the external device management system. And that's where that trust data goes in and is used to as part of the context for the policy evaluation.
Actually not going to cover the tutorial. I want to focus on the concepts.
Likewise, some of the basic mechanisms here of creating and destroying these verified access instances are just very mechanical, so we're not going to talk about those. The trust providers, we mentioned they support both user identity providers, either OpenID Connect or AWS's IAM Identity Center, and the device-based information. You can see they support Jamf and CrowdStrike as the initial mechanisms. We're going to go through the information that you get from those when we talk about policies, because that's really the interesting part of this. Likewise, verified access groups are not that interesting. They're just the way that you collect things and provide access through a variety of these endpoint configuration mechanisms. We're going to talk about the good stuff, which is verified access policies and how that's constructed. Zero Trust is all about policies, and having policy decision points in the right place with the right type of contextual information and a set of distributed policy enforcement points is what is at the heart of Zero Trust. AWS has introduced this language called CEDAR, which is their policy definition language, and we'll touch on that in some of the documentation. We're not going to do a deep dive on that today. So let's take a look. Their policy structure here, I'm going to make that a little bit bigger here, has an action, whether it's permit or allow, what they call the effect. They define a scope, which is going to be scoped or tied to certain principles or actions or resources. And then the condition clause, which is the most important part of it, because that's defining when and under what circumstances this policy should take effect. You can tell this is in preview. There's a couple of rough edges here. So, for example, they're saying the policy scope must always be kept undefined and essentially, I guess, apply to everything. And then you put the filters or the mechanisms in the condition aspect of it. And I think that's probably just an artifact of where they are in defining and using this language, this CEDAR policy definition language, and the way that it's tied into this new service. So policies, this is a pretty straightforward discussion of what they look like. They're either allow or deny, that is permit or forbid statements, and they evaluate the conditional clause based on the context that comes in to that. They have a set of exactly what you'd expect in terms of rich built-in operators, in terms of Boolean comparison types of things. And let's get to really the heart of this, which is the trust data that we get from these trust providers and how it actually works. So recall, the trust providers in this example are either the identity provider, AWS's IAM, or an OpenID Connect, or the one of those two device management systems that they support, Jamf or CrowdStrike. The information that you get, the context, is really what's critical here, because you have to know what's going to be in your vocabulary, what kind of data are you getting, so that you can then build policies around that. And you can see some of the examples are email address for the user, group membership, which is probably going to be the most commonly used. That's far and away the most common attribute, identity-based attribute that organizations use in their zero trust policies. And then from the device, you can get device OS, device security state, and we'll see in the examples the kind of information you would get from CrowdStrike or Jamf that can be used in your policy. Okay, they do provide this default context that's purely associated with the HTTP request, and this is what comes in with everything, regardless of your identity provider, regardless of the if you're using a device provider or not. So it's some basic information, not terribly useful. User agent string, which in some cases is all right. The host name that's being accessed, and then a couple of other kind of mechanical things here. If you're using the AWS Identity Center, IAM Identity Center, so this is where it gets interesting, because now you can actually see, I know the user has authenticated with this identity provider, and I'm going to get some information from them. In particular, you get the user's email address. You get a Boolean as to whether AWS has verified that email address. So that could be useful information to coordinate or to indicate, for example, if it's a corporate user, if they've gone through some sort of validation process. And then the group memberships. This, again, by far is the most common and will be the most commonly used attribute for determining access control. So that's going to be very useful. In terms of third-party trust providers, you notice they don't have a section on OpenID Connect. I found that a little puzzling, but presumably, if you're using OIDC, you will get similar information to this. I mean, I can't imagine you wouldn't get group memberships, users identifier, email address. Those are kind of basic table stakes that you'd expect, and are what is necessary. In terms of the device providers, they really have three mechanisms here. You can have a browser extension for Chrome and Mozilla to give you data from Jamf and CrowdStrike. So this is obviously, browser extension is running locally on the user's client, and it's doing some sort of API integration with the Jamf client or the CrowdStrike client, CrowdStrike agent that's running on that user's device. So it's not connected to, for example, the CrowdStrike Falcon cloud service. It's pulling this information locally from the device. So from Jamf, you can see you can get some attributes here. You can get Jamf's risk indication, for example, and the OS version, two pieces of useful information. If you're pulling from CrowdStrike, you would get the operating system version here, and you would get I believe it's up here, this overall assessment, which is CrowdStrike's metric that talks about the sensor and operating system configuration scores. So those again can represent some level of risk information that could be useful in your policy. Okay, so before we dive into the policy, let's take a step back. What we have is the ability to define access policies that are enforced through the AWS plumbing in front of your web applications. We can use information from AWS's identity provider or an OpenID Connect identity provider, use that contextual information in your policies, as well as get information from these Jamf and CrowdStrike as endpoint management systems. So here's an example of a policy. You can see you're allowing, this is a permit policy, and you're looking for, are they in a group that contains the word finance, and has their email address been verified? That's a pretty reasonable policy. This is something that you would think would make a lot of sense to define access or control access into a finance application. Here's another example where they've added in an AND clause to make sure that their JAMP risk is classified as low. Likewise, here's another example where it's not tied to any information from the identity provider. It's just checking whether CrowdStrike's overall assessment is a score greater than 50. And here they're looking at another set of attributes which has to do with the HTTP request based on a client IP address. And here you can see they're using the example, well, is it in my 10.0.0/8 IP address range, which obviously is a private IP address and is not the greatest example in the world because the user is running somewhere outside of AWS. Anyone in the world can have that same private IP address range. It's not a particularly useful example. And in fact, I would pretty vehemently argue that using IP addresses as a mechanism to control access is a very poor example. I can understand why they did it because that's something that is an attribute that's there. But for example, having a public IP address in there and saying, well, this is Sally's home IP address, which of course is a terribly terrible way to do it because her IP address could change and anyone at that IP address could now get access to it. But this is kind of very much counter to zero trust, which is where I'm struggling a little bit with kind of why they listed this as an example.
There is one part of this tutorial which I want to cover, which is the endpoint configuration, the DNS configuration.
So the tutorial is standard AWS, fairly detailed, gets you from point A to point B and shows it working. The DNS settings is important though because it kind of shows us how the system actually works. So essentially, what you do is you take your application hostname, in this case www.myexample.com, and you put a CNAME record in your your public DNS to have that map to an AWS endpoint. So you can see as this example, myapp.example.com actually maps to this ridiculous host name, which corresponds to essentially a logical edge on AWS's network. You can see it's going to be in a specific region, in this case, US West. So essentially what's happening is those AWS edge endpoints, or edge points, if you will, are going to act as the entry point, the logical entry point into your private network. So your end user will go to this URL here, and then behind the scenes, the traffic will go through that endpoint, go through the various pieces of AWS plumbing to your load balancer, and then through the verified access piece for policy evaluation, and ultimately to your application. So what this means, of course, is that these applications need external DNS entries, and that has some implications in terms of the speed at which they can be created or they can be changed.
Now, let's talk about the pricing for verified access.
There's two components to it. There's an hourly charge for each application, as well as a charge for the amount of data processed. And let's take a look at the details on this. So application hours, each hour that an application is running, there's a charge, and each gigabyte of data, there's a charge associated with that. Obviously, the data is, well, I guess both of them depend entirely on your applications, the types of work that it does, the types of users that are going to be accessing it, when they're going to be accessing it, and of course the amount of data that is going to traverse from the user to the application or back. So let's take a look. Applications in general are 27 cents an hour. And if we do the math on that, at 27 cents an hour times approximately 732 hours per month, that's about $197 per month per application, or just under $2,400 a year per application. Data is 2 cents per gigabyte. I don't have a comment on that because it's anyone can do the math on how much data an application runs or uses. But I really want to dive into the application hours. So $197 a month, around $2,400 a year per application. That's independent of how many users are accessing it. Clearly, the number of users are going to impact the amount of data. But most zero trust access solutions, whether they're doing it for on-premises users or remote access, charge on a per user basis. In fact, many traditional VPNs do as well. So it's X dollars per user per year. And typically those systems have little or no limitations in terms of the number of applications they're accessing them. I'm hesitating a little bit because many vendors have tiers around that, where they might have a very basic tier that might limit you to, let's say, 5 or 10 applications, and a higher level of service, the bronze, silver, gold model, where maybe there's no limits to the number of applications. So AWS has taken a different approach, of course, which is charging, let's call it $2,400 a year per application. Now, is that a lot? Depends on how many applications you have, and depends on what types of applications you want to use this to control access to. In my mind, 5 or 10 or 25 applications is not a lot of applications, because the principles of zero trust are really around using it to control access for all users, for all resources, and all applications. That's one of the core tenets of zero trust from the original definition and from the NIST 800-207 document. And clearly, if you start having production applications that are running 24 hours a day, 7 days a week, and you have 10, 20, 30, 50 applications, this can get very, very expensive. 10 applications times $2,400 a year, $24,000 a year. That's not too bad. That's pretty reasonable. But if you've got 100 applications, then you're up at $240,000 a year. That's a pretty considerable investment. And if you've got hundreds of applications, I can imagine that this would get very, very expensive very, very quickly. Of course, this is per hour, so you could have a model where your applications are only running in a on demand or as needed, right? There's many variables here. It's important to go into this with your eyes open and understand, do the math for your environment. Look at the data process as well, but understand how many applications you're going to have and what the associated cost is going to be for this. And also think about, does this solution make sense compared to perhaps other zero trust solutions that can equally well tie into your identity provider, because they all do, can use your endpoint management system, but can also control access to non-AWS resources. I'm not slamming AWS here. I'm just trying to make sure that you as a listener understand the limitations and constraints around this. This may be a great solution for folks who are very AWS-centric. I don't want to dissuade anyone from doing that, but it's important to, when you make vendor decisions, when you make that platform decisions, to fully understand the constraints and the limitations around what it can do and what it can't do. So there we have it. We've gone through an overview of the concepts, the structure, the contextual information, and the policy model of AWS's preview service, Verified Access. I want to commend AWS for creating this and for encouraging their customers to embrace the principles of zero trust and giving them some tools to start their journey of defining and enforcing finer-grained and contextual access controls. This is a new service. It's in preview by AWS, and I think we can expect it to only expand in terms of its scope and capabilities as it moves on. I think that there's definitely some question marks in terms of the pricing, and I think that it'll be interesting to see how enterprises use that, and if AWS understands and gets feedback if perhaps this pricing model is counter to the way that is expected or is in fact going to be an impediment to broader enterprise usage. I don't know. I think that along with you, I'm looking forward to learning and seeing how this progresses. So I hope this was helpful. Please let me know. You can provide feedback to me. You can email me info@zerotrustsecurity.guide or reach out to me on LinkedIn or on Mastodon, where I'm jason.garbus@infosec.exchange. Thank you all for your attention. I hope this was useful. Take care and have a good day.